So I asked you on the board a couple of things. I said on the back of your packet, answer these 4 questions that I have on the board. So that's going to go in the very back page of your packet. And then while you're doing that, I'm going to come around and check your homework. Yes, on Monday I assigned homework. It was pages 9 through 13 in your packet. If you weren't here, make sure you show it to me tomorrow. But if you were, I need to see it now. So I'm going to come around and check those while you guys answer these questions on the back page of your packet.
Hmm?
Yeah, I cleaned up. Guys, make sure you're working. Yeah, right on the back page of the packet, the blank page. Okay, let's try this again, guys. Welcome back. Now do the assignment that I asked you to do on the board. Yeah. Yeah, it should be right. I think it's right there. It's right there against the wall. Oh, no, are you sure you have stuff? Sure, no?
No.
All right, well, there's a spare one up there you can take. Were you here, Brian?
Yeah. I think so.
Yeah, very good. Yes, but from now on, you need to have them here. Sorry, is this still too small for? There's the 4 questions. That's. Yeah, all the questions. Okay. After. Yeah, over here. Okay, so don't forget this last question up here. It does say name the 5 agents of erosion and one landscape feature created by each. We have not done waves or running water yet. So if you don't have those landscape features, that's okay. Get the other 2 though.
That is fine.
All right, let's do this. So hopefully this was stuff that all came rushing back to you. If not, hopefully you thought to look up the answers as you were going through this. This is all stuff we did before your little mini break there that you are, yes, responsible for knowing. How can we very quickly and easily define weathering? Breaking down of rocks. What do they get broken into, by the way? And what are those called? Into sediments. Be comfortable with the actual vocab words. So breaking down of rocks into sediments, which yes, are just smaller pieces of rocks. What can we say about physical versus chemical weathering? I'm just gonna do a little T-chart here. Okay, what else are some important differences or similarities? So if chemical changes the chemical composition, what else do we know about chemical weathering? Yeah. Okay, so cold and moist. This is warm and moist. How about a quick definition of physical weathering that we could put there? What's it change? What does physical weathering change about the rock? How it looks. So size, shape, and what do you say, Dakota? Makes more surface area. I'm gonna make that its own bullet. I'm kind of treating this back page here like a review sheet. So you will want to have all of this stuff there. How can we say quickly what erosion is? Movement, transportation, something like that. Movement of sediments. Something that implies they're moving. What's one agent of erosion that we already did and a landscape feature that it creates? Glaciers, they create kettle lakes. What else do they create? Because I'm sure not all of you put kettle lakes. Oh, you all did. Striations. Add these if you don't already have them. Striations and grooves, remember, they are basically the scratches that the rocks underneath the glaciers created. So kettle lake, striations, grooves, there's some more. They create valleys. What do those valleys look like? U-shaped. Anybody throw any other vocab words out there? Okay, a couple more that you should be familiar with are moraines, drumlins, Finger Lakes, Great Lakes, and then also remember, are they sorted or unsorted sediments? So unsorted sediments. Those are absolutely things you just got to remember go with glaciers. Do you need to know exactly what a moraine or a drumlin or a kettle lake is? No, but you do need to know they go with glaciers. What's another agent of erosion we've done? Oh boy. Wind, thank you. So we did. All right, what does wind create? Sand dunes. Any other vocab words that you remember go with wind erosion? Okay, so you should also know sandblasting. And desert pavement. What's another agent of erosion we covered so far? Gravity. Some vocab words that go with gravity. Give me an example of gravity erosion. How about that? Rock falls. Landslides. Mud flows. Again, sorted or unsorted? Unsorted. You know what I forgot? Wind. Back up to wind. Are those sorted or unsorted? These ones are sorted. All right, there's two more agents of erosion. We haven't done them yet, but can we list them? Running water. Heard running water, and I heard the fifth, sorry. Those are waves. So we'll leave those ones blank for now, but we're actually going to start running water right after we go over the homework. So this is stuff. This is the extent of the stuff that you're going to need to know just off the top of your head. Again, we didn't really define many of these things, but you do need to know what they go with. So landslides, gravity, kettle lakes, glaciers. All right, so we're going to go kind of quickly through the homework, but I would like you to stop me if you were confused about any of them. So number one, the answer is 3. So with that one, you'll notice I crossed off things. This question specifically asked about positive effects on the economy. So if number 2, the usable water reservoirs were reduced, that wouldn't have been a positive thing. Same with deposits of fertile soil were removed. That's not positive. Now, yes, 1 and 3 are both positive. Why is the answer not number 1? The glaciers, we never once mentioned anything about them making oil or natural gas. That's not part of glaciers, so that one's not it. All right, number 2, the answer is 2. Whenever you find an igneous rock sitting on top of a bunch of sedimentary rocks, it was brought here by something else. New York State, the answer is almost always glaciers. Which one of these would be present in glacier deposition? And that would be unsorted gravel. Key with glaciers is they're always unsorted. Number 4, what causes the movement of glaciers? It is the gravity. Answer number 3. The velocity of the glacier. Now, I never mentioned anything about velocity of glaciers, but if glaciers are going downhill, what's going to cause them to go faster? Just like a sled going downhill, it's going to be the slope of the land. Answer number 1. Again, glaciers make U-shaped valleys. Answer number 1. Number 7, you did have to read it more kind of carefully. It gains more snow than it loses. Means the snow's piling up. So again, you'll see I crossed off the 2 decreased ones. The glacier will increase in size if it gets more snow than it loses. And because it's getting more, will it retreat or advance? Remember, retreat means going backwards, advance going forward. So if it's getting bigger, it'll go forward. Walking around, I did notice a bunch of wrong answers to number 8. It was just really easy for me to glance at that one. The key with number 8 is a glacier will make unsorted sediments. That's answer number 4. Now, while number 1, there is a bunch of different sizes, they're organized. Glaciers don't organize anything. Same with number 2. You did have to read the reading here to go with this picture. It told you that the arrows were representing striations. And those striations showed that the glacier was moving towards the south, both the southeast and the southwest. Answer number 4. You did not need to do number 10. That actually, you won't understand how to do that till next chapter. Number 11, the thickness of the ice sheet is best determined by the grooved bedrock on the top of Bear Mountain. So the bigger the grooves, the bigger the glacier. Not the scratches on loose rock at the mouth of the Hudson River. It's not going to scratch loose rocks. They're going to pick up the loose rocks and move them. It's going to scratch the bedrock. How are the striations made for number 12? That's answer 2. Rocks at the bottom of the glacier were dragged over the bedrock. Remember, a moraine goes with the glacier, and anything to do with glaciers are going to be unsorted. So many different sizes and not layered. Layering is a type of sorting. So anytime you see layering, that's really just saying another way of saying sorted. I think we talked about 14, maybe we didn't, I can't remember. The soil around here in most of New York State is thin and rocky. That's because the glaciers took away a lot of our topsoil, so it's not going to be thick. And rocky because it's going to leave behind some rocks. But here's a teachable moment. I can't remember if our class did it. What's the word residual mean? So this is a vocab word you need to know. So I'm no longer going over homework. I'm teaching right now. So kind of tune back in. What do you hear in the word residual? Reside or residue or resident. My best way of explaining residual is picture a big bowl of Kraft macaroni and cheese, specifically the orangish yellow macaroni and cheese. You got a big old bowl and you move all that macaroni and cheese into your stomach. You erode it away from the bowl and deposit it in your stomach. You eat it. How's the bowl look when you're done? Yellowy. It's got the cheese left behind usually. So unless you've licked that bowl out, there is some cheese residue. That is Residual cheese. Cheese that is left behind. So residual soil, what do you think residual soil is? Okay, soil that was left behind. Meaning it was not moved. Born and raised where it stays. So in other words, it wasn't touched by a glacier. So anytime you see residual, it means not moved. What do you think they call soil that has been moved? That would make sense. It's not though. The opposite of residual, let's put that, I'm gonna run out of space, is transported. Transported soil is soil that has been moved. So I know that one probably doesn't need an actual definition, but it is the opposite of residual soil. All right, let's wrap up these last couple of questions here. I think the glacier or the gravity one was pretty easy. So the best evidence that erosion has taken place, that would be sediments observed at the bottom of the cliff. How'd those broken rocks get there? Gravity pulled them. What acts alone to create avalanches and landslides? That's going to be gravity. Which one of these is gravity not the driving force? So in other words, which way does gravity pull sediments usually? Down. So we want one that's going to cause things to move up, and that is moisture evaporating from an ocean. When moisture is evaporating from the ocean, it's going up into the clouds. All right, and these last three are super easy. Gravity caused this landslide. Glacial movement is caused by gravity, and the water flowing in a stream, again, is because of gravity. 2 questions about wind here. There's a lot going on in these questions, and it is important when you get one of these questions to read all the words. So hopefully you saw that there was this rock, and it was partially exposed at the surface in a windy desert. So here we have wind carrying wind-driven sediment. That sediment's going to bounce off the side of this rock all day, every day. What's it going to do to this rock? Wear it down, make it smaller. On that side, hopefully you notice that answer 2, the rock had gotten smaller and more worn away on this side, right where the wind was hitting. Number 3 was long and drawn out, and based on the pictures I saw when I walked around, many of you got this wrong. So we had loose sediment here. A sand dune was going to develop here. They wanted you to draw that sand dune from this side. And the key with sand dunes is wherever the wind is, that's the gentle side. So I saw almost everybody's sand dunes were wrong. Please go and fix your sand dunes. The gentle side has to be on the wind side. Gravity, glaciers, and wind erosion, not so bad. All right, we're going to get into stream erosion. But actually, before we do that, let's get the factors that affect deposition. Starting in lab today, you guys are going to be working on the deposition lab. So some of you already did first period here. So there is some things that affect deposition. But before we get started with what affects deposition, let's define deposition again. So at the top of the page, what is deposition in some simple, easy to understand terms? Yeah, let's get rid of the word depositing because I think that kind of messes with some people. What does depositing mean? Dropping off. If you want to say depositing, I'm fine. Hey, does dropping have 2 P's? Thanks. Dropping off of sediments. So when is wind going to drop off sediments? When the wind stops. When are glaciers going to drop off sediments? When they what? When they melt. When is a river going to drop off sediments? When it dries up is one thing. Yep. There's some more that you can think about for that though. Yeah, and what happens when a river reaches? It kind of stops. That's the key. Is that so when a river stops, it'll drop off sediments. Let's go ahead and get all this. So the first thing what you may have noticed is velocity has a lot to do with when sediments get dropped off. So right there on the top of page 14, factors that affect deposition, one of them is going to be velocity. So as the transporting agent slows down, sediments begin to settle out. So when the wind slows down, when a river slows down, sediments begin to be deposited. So when sediments begin to fall out of, did I give you the wrong one? Did I give you the extra one?
I just answered A from this one.
Okay, back to this. When sediments get dropped off because the river slows down, not every sediment will get dropped off at the same time. There will be differences in when a sediment gets deposited based on their shape, size, and density. What shape, not the three of you that were just in lab, but what shape sediment do you think will get to the bottom of a lake first when the river enters the lake? Shape. Circle, you guys got it. Round, can you guys picture a round rock and a flat rock? Drop them both into a pond at the same time. What's different about how they get to the bottom? The circle goes quicker. What's it look like when that flat one goes down? Does it just go whoop like that usually? How do those flat rocks usually get to the bottom? You got it. So a bunch of you do that wavy motion with your hand. Picture those skipping stones that I'm sure at least you've skipped a stone once in your life. If you haven't, you've missed out on great childhood then. If you have never skipped a stone, when that flat rock hits the water, it goes down. It's very similar to if I was to drop a sheet of paper versus a balled up piece of paper. That paper floated down side to side. How about size then? What size sediments do you think will go down to the bottom faster? Bigger ones. A bigger rock will reach the bottom of a lake faster. And how about density? More dense. Oops, sorry, went too fast. So if everything else was the same, so they were made out of the same thing, they were the same size, shape, rounder particles settle out faster. Size, larger particles settle out faster. And density, more dense particles settle out first. So this is how sediments get sorted. They get sorted by their size, shape, and density. One thing the regents will do to mess with your heads is they'll use the term settling time and settling rate. What's the difference between time and rate? Rate is how fast, yep, and time is just how long it takes. So if I'm traveling at a fast speed, what's my time? So fast or slow, but so if I'm going fast, is my time going to be short or long? Short. So you got to be careful with that. Smaller numbers mean a faster time, but smaller numbers mean a slower speed or rate. So if your car is traveling 30 miles an hour on the road versus 60 miles an hour on the road, it's going to take you longer to get somewhere if you're going 30 than if you're going 60. Just be careful with the words they use if they're using rate versus time. They do mean two different things. All right, so sorting of sediments. Sorted versus unsorted. We've kind of already talked about these, but we've never put them in our notes. So sorted is when large, more dense or rounder particles settle out first. And the agents of erosion that sort are the 3 W's: running water, waves, and wind. The unsorted, or when sediments get dropped off in no particular order, all mixed up, that'll be glaciers and gravity. So I do think that's helpful to remember. The 3 W's are sorted. The 2 G's are unsorted. There's a couple different kinds of sorting depending on what's happening. So right now I'd like you to picture a river. And if you can't picture a river, I'd like you to picture a water slide. Because a water slide really just acts like a river, right? What makes a water slide go faster or slower, by the way? The slope. So you guys should kind of remember lazy rivers go slow because they're not much slope at all, versus those really big water slides that Darren, like, they go fast because they're very steep. What happens no matter what kind of river you've got, when it, or what kind of water slide, what happens when you enter the pool at the bottom? You stop. First you slow down and then you stop. So when we send a bunch of children down a water slide, do they all stop at the exact same spot in the pool? Some go farther, some go less. Who's going farther? The lighter kids. Those little kids. I swear the first time, and maybe this was me as a parent, but the first time my littlest daughter went down a water slide, I swear, well, here's how it went. First, she wanted my husband to go down first because she just wanted to see what it looked like. So it was just a little water slide at a hotel. She was really young. He just went down the water slide and kerplunk right at the end of the pool. Didn't look dramatic at all. Poor little Mallory, who's tiny to begin with and was little then. She's like, I can do that. That wasn't bad. She went down that water slide, I swear, at 100 miles an hour, did a couple of somersaults over the pool and practically landed out of the pool because she was way tinier compared to my husband. So just like you guys with water slides, the bigger you are, or the smaller you are, the farther you'll go. The bigger people end up just kind of kerplunking at the end of the water slide. The smaller people skid across the top like poor little Mallory did. What that would create So if I did that with rocks instead of people, that would create what is called horizontal sorting, where they get sorted horizontally. My husband at the very bottom, end of the slide, my littlest daughter way across the pool. So they get sorted horizontally. This is exactly what happens when a river enters a lake. You could probably also picture this walking into Lake Erie, at the beaches around here in Lake Erie. What rocks do you hit first with your feet? When you walk in, how does that feel on your feet? Hurts, doesn't it? Because there's big rocks first. Then you take a few steps out and you're into little tiny rocks and just sand. That's because the big rocks get dropped off at the beach first. The smaller rocks get taken out farther. Right, and waves act just like this. So waves act, they will drop off the biggest rocks first and then carry with them the smaller rocks. So this is where they get sorted horizontally across the beach. And that's different than vertically. Vertically would be, let's say there was a landslide and the landslide ended in a lake. So they all kind of get dumped in at the same time. Or if I took a bucket of junk and just dumped it in, they'll be sorted vertically, which means up and down. So they settle from the bottom to the top, largest, more round ones first. Once you get this, that's as far as we're gonna get, and I will tell you your homework is page 6. 15, there are 6 questions there for you. But I do need to see your purple reference tables, because if you guys remember, I forgot to give you credit, the extra credit that I offer with those for first quarter. So I'm offering 2 points extra credit if you have your purple reference table. Yeah. Okay, I'll give you credit anyway. So again, if I could just see it, McKenna, that's good enough. I just need to see that you have yours. I got it, Taylor. Good, good. You got yours, Nick? You lost yours, okay.
Oh,
Yeah, your reference table. Okay, good, 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 good. Good. Good, good, good. Okay, everybody's got it, nice. So that'll be 2 points averaged into your not average, just plopped onto the end of your second quarter grade. So I will get that in later today. So your report card should be 2 points higher than what is currently in there for quarter 2. Yeah, you're welcome. So again, your homework is page 15. There are 6 multiple choice Regents questions. Yes, of course, you could just circle answers, but there's only 6. Read them and try them, please.
the